Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robbie Russell. On this episode, Justine Gehring, who is currently an AI research engineer at Moderne. Justine joins us from Montreal, Quebec in Canada. Justine Gehring, we're so glad to have you join us on Maintainable. Welcome.
Hi, it's nice to see you, meet you.
Likewise. So as you reflect on your experience in our industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
I feel like you must have gotten so many different answers to that question. The normal themes will come back. Good documentation, always key. Reusable code that someone can jump in. Someone joins the company, even if they're senior, they need to be able to understand that code within the first, week or so. I think it's funny because I come from a different background. I come more from the research, academia, and maintainable software in that field is a little bit different, or rather it's more forgotten to keep it maintainable, if I can say. Take a little dig at my my old field. Definitely you want to make sure that, when they're doing experiments, they're coding models, AI models, putting those out. You want to make sure those are also usable and testable. So a lot of people will have benchmarks and results, but then no one can get the same metrics as they did. So that's definitely maybe an answer I wanted to give. That's maybe a little bit different than the ones you might get usually.
I'm trying to remember. I feel like I had someone on the podcast maybe within the last few months, and they also kind of work in the research area. And they were talking about how quite often software projects that you might work on need to might need to rerun it maybe, but not necessarily. It's different because you're not like adding new features down the road. It's kind of like this is a kind of a snapshot in time, get some sort of results out of that you can then talk about or publish. And here's the supplying source code to support that. I mean, I don't work in that particular, like say, sector, what have you. Is it a matter about like being able to reproduce the results, or can you maybe tell us a little bit like what's different and what's your perspective on that and how it does differ from, say, someone that's working on a software project at a product company or something?
Yeah, absolutely. I think it's twofold. There's definitely the reproducibility, and that's just for like ethics of doing research. You want to make sure that the numbers you're giving out, saying, "Oh, we beat this benchmark by 5%," you want to make sure people are able to reproduce that to kind of give some weight to your claim. So there's that. But there's also academia is all about sharing knowledge, code as well, software. And when you have these junior researchers that want to take a project that you did, maybe sometimes it's going to be old projects as well. It could be 2-3 years that no one has touched that model. Because sometimes once you get the paper out, you're a little bit done. Put it on the back burner.
Is 2 to 3 years considered like old in research world?
Isn't that crazy? Yeah. Yeah, that's a little old. It changes so quick. I'd say even now, a year is considered old sometimes. But these models, even though they might be old, they might still have some merit to them, and some junior researcher might want to pick them up and try to add new things to them. And they'll be sure the paper will have a lot of explanations, and that's maybe something that regular software doesn't have. We do have that sort of write-up that's kind of obligatory for any releases. But, these developers, these researchers would tackle a model and they might not even know why a certain thing was done a certain way. And unless they have some knowledge or context, or they end up writing to someone who was on that project, they might never really know why a certain function was used, like an activation function. I don't know if that's something that means anything. Sometimes when we're designing these models, they'll just be what's kind of the state of the art, what's understood to be a good start, but sometimes it isn't. And it's important to explain why we chose a certain, function, a certain way of cleaning the data, and kind of have this explanation. And without this being there, it's really hard for people to pick up and understand the nuances on where a model is going to do well and not well.
Out of curiosity, what was your path like to becoming an AI research engineer?
I started in computer science, went to McGill for my undergrad. Actually started in business, ended up doing a elective intro to programming, and I absolutely fell in love with it. I always really liked math, but I didn't want to do just pure research and math because it's a scary world out there to just be doing that. You kind of have to be in the top 1% of mathematicians. So when I found programming, I was like, oh, this is perfect. This is little riddles that I get to solve, and I'm still using math in a way I really enjoy. So I switched over to do computer science, and then from there, I took a machine learning class around my last year, and from there, I was like, okay, this is really cool. This is definitely something I would see myself doing a lot, and I like also probability, and I liked graph theory a lot. That's, my love of math that kind of comes out again. So what's actually pretty ironic, I started by saying, oh, I'm never going to do NLP, never going to do anything with text. I was like, that's too easy. I kind of wanted to be more special and do something a little bit different, unique kind of machine learning. So I started in graphs, doing graph neural nets. But one of the applications is code, right? Because an abstract syntax tree is a graph. But very quickly, we saw transformers, and which is basically the architecture behind all these, ChatGPT and all that. And from there, it was like, all right, well, there I am, back to text.
Hey folks, it's me, Robbie. I want you to take a moment and close your eyes. Now picture your code and your applications as a symphony. Now to keep that symphony playing smoothly, you need an orchestra of tools. That's where our podcast sponsor, AppSignal, takes center stage. They combine the elegance of error tracking, the precision of performance monitoring, and the harmony of logging into one symphonic suite. Whether you're composing with Ruby, jamming with Elixir, orchestrating with Node.js, or harmonizing with Python, or maybe even a little bit of flourish of JavaScript, AppSignal's got the sheet music for you. And here's the crescendo. Plans start at just $23 US a month. That's gotta be music to your budget's ears. Plus they're certified ISO 27001 and they dance the GDPR and HIPAA compliance beats. So don't miss a beat, my friends. Head on over to appsignal.com and tell them that your good friend Robbie from Maintainable sent you. Now, open your eyes and let the symphony of smooth coding begin. Let's get back to our show. I'm curious about, that. I don't know a lot about that world, so I'm fairly ignorant on that. So I'm going to assume that a certain subset of my audience, or maybe a lot of them, are maybe ignorant about this too. So a couple things you said there, I'm like, I have no idea what that meant. So, and that's just my own ignorance, and I didn't go through a normal computer science program or anything when I learned to start building software a couple decades ago. It was like, how do I just make some web forms work on the internet? It's since evolved since then quite a bit, but you're coming from a more of a math background where I feel like I've not barely used enough math to warrant that. And so do you feel like that's been interesting to kind of work in an environment where you're getting to tap into that particular skill set that you have and that interest in math, but you're also maybe working around or doing research on tools for a lot of people that doing programming things that aren't necessarily, it's all about writing text and understanding the code that we're using to communicate. And it's an abstraction of instructing computers to do things. What's your perception of like what software engineering is actually like from what you maybe thought it would be like before you took that first computer programming class yourself? I'm curious about your perspective on that. I suppose just being like, did you have an idea that, well, being a computer programmer would be like this, but you're like, well, there are a certain subset of that are like that, but there's actually a bunch of software developers like us over here that are like, well, that's not quite what it's like for us either. So where's that?
Yeah, definitely. When I kind of realized that there was a whole other world, more, software engineering versus computer science, was definitely when I started working at Moderne, the company that I'm at. And it's, all these different tools that they use, that there's so much knowledge and intuition that the more senior developers at our company will have, that I'm still learning from every day. And there's definitely more of almost a business part to it that I hadn't thought that it would be. Why do you use this library versus this library, or this framework versus this framework? That's been really interesting to kind of gauge the pros and cons. It's definitely a little bit different than what I expected.
Do you think, when I'm just going to dig a little bit more into this, you brought up frameworks, or like why certain teams or people might pick one framework versus a different framework. And are there frameworks that you're working with in your own stacks of tools that you're working? But like, it's interesting from my perspective. I've tried to articulate this over the years. It's kind of like a sense of taste in a way, and it's less like what's right or wrong, like what's the best thing for it. It's more like what am I going to enjoy working with for a long period of time. And I don't know how to codify that into some sort of like scientific what's the best possible framework to use for this particular thing. It's just like, well, a lot of people seem to like this, or this resonates with me for some weird reason. And that's gets into this probably interesting aspect of language and what we spend our time thinking and writing and consuming the documentation and the community of people that are supporting that framework.
I think there's again two parts to this where a library you might choose to go with it because it's something you're knowledgeable in, you've used it before. Sometimes it's just like, why do you use the toothpaste you use? Well, because that's the brand my parents used, right? And it's a little bit like that's what my mentor showed me 5 years ago. So there's definitely that where it's like, and I think that goes into the category of, is the developer happy and feels comfortable and can be a bit more productive, right? Because when you know what you're using well, the tool you're using well, you'll be a little bit faster. You'll know where it's going to be harder to code a certain thing versus that's going to be super easy. Give me 1 hour. There's that, but then there's also thinking about a little bit more in the background, what they're doing. Some frameworks are going to be faster for certain things, or they're going to be well built for certain applications. And what I meant by, it goes back to a little bit of business. You have to think about, what am I trying to solve? What might I want to solve in the future? And how do I make sure that the work I'm doing right now won't have to be scraped for another framework? Of course, we can't always know ahead, and there will be times where you have to refactor and migrate from one thing to another, but definitely I think it's important to think about stuff like that. And also just, how good the library is, the framework. So coming from the machine learning world, I was coding in Python because that's basically, my brand of toothpaste. And when it was time to start deploying, I realized that I was going to be a lot faster if I used C++. And thankfully, there's a Llama C++, which is a great framework, open source, that can take models that, who cares how they were trained? They just take those weights and can then run it in C++. And it was 3 times faster than using Python CPU. So it was kind of like, okay, well, this is what we're going to go with forward. And that's what we've been using so far.
It's interesting. Let's pivot back over a little bit. I'm kind of curious because I know about you co-authored a report for O'Reilly titled AI for Mass Scale Code Refactoring and Analysis. So could you give us a little bit of an overview of what this report is about and what inspired you and the co-authors to write it?
Yeah, absolutely. I think this book was kind of an answer to a question we kept getting, which was, let's use ChatGPT to refactor and let's bring everyone to Java 21 or whatever version we're on now. And it's kind of an answer to that, to being like, yes, ... but here's how we would actually recommend doing it. And here are the pitfalls. And here's how we actually recommend you use AI to actually get some value at scale. So that was basically the idea. It's interesting. I really like the title because the last word, it's more like analysis. And I think AI is really good at doing impact analysis, which is not something we give it credit for often. We'll normally say, oh, it's great at generating, it can generate text, images, haikus, voices, anything you want, audio. But it's also very good at being able to ingest a lot of text and pick out patterns, and decipher patterns within what you're looking at. One of the applications we have where you basically can look at all the method declarations you have in your code, you get a numerical representation of that. And basically, it's not really important to know what goes in between, but the end product is that you have this scatter plot where you'll have, say, in the top right corner, all your getters and all your setters are going to be next to each other. And then if you look at the bottom left, you'll have methods that have to do with logging. They're going to be together. And so basically, you have a new way of looking at your code that can be, a large repo and walk through your different methods and find if there's any patterns, if there's any things that maybe you would want to refactor. If 2 methods are very similar, they're going to be next to each other. But if you realize that those methods maybe should be encapsulated into one, or there's a better way to design this, that's going to be one way. So that's why I really like that we focus a lot on the impact analysis first, which is sometimes the first step before refactoring.
Who do you think would benefit the most from reading this report? Is it aimed for software engineers themselves or other like researchers or like engineering managers that are kind of trying to figure out how to understand how AI can fit into their workflow? Because I know there's a lot of teams that are kind of trying to figure out, like they might be giving out some Copilot licenses for some of their team members, or they're saying, none at all because we don't know if we can trust this yet, or cursor out, there's all these other tools popping up and stuff as well, or there's scenarios where developers are copying and pasting code into ChatGPT and their employer doesn't know that they're doing it. But yeah, maybe talk about the ideal audience for this particular this book.
That's a really good question. I'd say definitely managers first and foremost. Like you said, a lot of people are scared of AI. A lot of people hype it up too much. And like a lot of things in life, the truth lies somewhere in the middle. AI is great at some things, it's okay at others, and it's scary bad at others, right? I think it's also interesting for researchers. Definitely, I've, told my ex-colleagues, the people who are still in academia and research, to read it because you deal with, certain models, certain tools. You read about them, you work with them, you do some sort of benchmark task, yada yada. But it's kind of reassuring to see that at the end of the line, there is an application in industry and that we're actually, making the lives of some developers better with those tools. So definitely that. And I mean, I know a lot of also software engineers are just in general very intrigued by AI. People that didn't, I was lucky that I was studied in it, but some people are only now getting into it, that they might be curious about ways that it can, can use it. And we try to be very neutral, very fact-based about what AI can do for large-scale refactoring and analysis, because that's the world we're in. We have a lot of also, user data. We actually see it being used on, thousands and thousands of repos. So we can actually say with a lot of certainty where it does do well.
I'm curious, thinking about how you mentioned that a lot of these tools are maybe perceived, we get like there's a lot of attention focused on code generation or just generation in general, and we talk about like how maybe you can do things like you're talking about, like analyzing an existing code base and maybe putting together a scatter plot or something, and you can kind of look at your code base a little bit differently than you normally could by just browsing the thousands of files in your code base. And especially when you're someone coming to a project and trying to make sense of how this thing all fits together, and it's a big effort to get to that point where you can kind of really understand and have some clarity around like how everything kind of fits together, if anyone ever actually gets there when they're joining an existing software project, is maybe another topic, but they try to wrap this all in your head and contextualize everything. So I'm curious about what sort of trends are you seeing when it comes to how software can be a good tool for maintaining older legacy code bases and maybe helping them get up to speed or getting them updated or refactoring things. Like are you seeing a lot of tooling there, and a lot of teams are able to leverage that and help guide them? And is it doing a lot of the code for them, or is it just helping point them in the right direction, or kind of somewhere in between?
Yeah, definitely. I do think, we internally, a lot of our developers use Copilot and Codium or other alternatives, coding assistants in general. They definitely, there's some code that is predictable. There will be a lot of times that we'll accept the suggestion, but that's a different experience when you're coding with it, right? It's kind of like if you're coding with literally a buddy next to you being like, oh, what if you did that? Oh, is this what you meant? And it helps you speed up a little bit, definitely. I think that when it comes to using it at scale to do some sort of refactoring, you would expect it to be good, right? Because you have this boring task, which is to go find all these instances that this library was used, or if you want to change, an argument or whatnot, that's kind of a boring work. You want to be writing new features. So how do
I
you
might argue with that, but
That's my opinion, but I'm also coming from research, right? I'm always thinking about the next feature, the next thing. And even like the more fun parts of refactoring are going to be kind of the design part, which is a little bit more where you have to, it's a puzzle, it's something you have to solve. When it goes to just changing all the methods, foo to bar, that's the kind of thing you would think an AI would do well. It does that kind of repetitive work well, but what we found is that actually it doesn't, because the 1% of the time that it doesn't, if you have a lot of occasions that you're calling it, you're using it, you have these errors that are going to get propagated, and you're still the bottleneck if you're not trusting the output of those models. You're still the one that has to look at every single change that was done and verify it. So sure, you don't have to type it out, but there's there's this new way that you're going to be interacting with it that actually can also lead to a little bit of decision fatigue. And that's where you can make mistakes because you're not actually looking very well at what the code is doing. And, we did this experiment internally. So you wanted to put the default case last in a switch statement. That's, very common as a rule that people like to do for their code bases. So at Moderne, we have something called the OpenRewrite, which is our open source little brother, if I may say. And it's basically what Moderne, uses to do this refactoring automatically. OpenRewrite takes basically your code, parses it, and it is sort of a super boosted abstract syntax tree, or AST. We call them lossless semantic trees because they contain a lot more than what an AST would. They have white space, but they also have type attribution, which is super, super useful for any kind of refactoring. So once we have a recipe, which is what we call these pre-coded transformation, which uses OpenRewrite. We have this recipe that can do this action for you of putting your default case last in a switch statement. So we wanted to compare that recipe that's, always going to be correct because we're using basically the syntax of the code to do that switch. We want to compare that with calling OpenAI and see what would happen. And it was actually a very enlightening kind of user experience where we say, all right, whenever you see a switch statement, and we would kind of cheat and use a recipe to gather all of those switch statements to not make it too hard on the AI either. So we send the switch statement, we say, okay, put the default case last. And it would, but then it would switch the orders of other things. And that's a big, no, that's not what we asked. Okay, but that's fair enough. Maybe I should have been clear. So we changed the prompt to say, don't change any of the other cases. Don't change the order. And then it did a little bit better, but there was still about 1% of the time where it did not work, where sometimes it would change the order of the cases, but it would still keep the fall through logic. But sometimes it actually changed the behavior of the code. And that's the 1% that really scares me. Because if you have 1,000 switch statements, then you're down to 10 errors that completely change the logic of your code. And it might be something you don't catch very quickly. And that's the part where it gets a little bit scary. And we think it's very useful to have AI be a coding buddy. But when it comes to actually using it at scale, it's just something we're not comfortable with.
At least not yet, in theory.
Yeah.
Maybe we'll get there. I'm curious, can you tell us a little bit about what your product does?
Yeah, absolutely. So like I said, Moderne is built on OpenRewrite, but it's meant to use OpenRewrite at scale. So OpenRewrite is one repo at a time. It's open source. Anyone can go ahead and try it on their code, run recipes. You can also write recipes. And Moderne basically took that and made it usable at scale. So instead of having to run one repo at a time, reparse the repo each time you want to run a recipe, we have basically serialization technology to be able to do this completely at scale. That's the idea behind Moderne. There's also a builder in there, the platform where you can go and build your recipes in a way that's very intuitive. So we have these like building blocks of recipes that can be used to basically create a whole migration that you want. So if you need to change all your methods foo to bar for some migration, but you also need to change the type of this, or you want to add a couple extra changes that fit the conventions of your company, you can have this recipe written basically just by using the building blocks that are already there. So that's basically the idea. So we have a couple of tools in there that's very useful. It's open to the public to use on a couple over I forget how many repos we have now, but we have a lot ingested in there. So there's definitely going to be enough for whatever you want to try out. And all our recipes are there as well.
Interesting. And what tech stacks is OpenRewrite primarily kind of targeting or working with at the moment? Is that like Java and things? Or
Yeah, it's definitely we started with Java. We've expanded now. We have Python and we have C# as well. That's in the works. They're basically usable. Everything's good to go. We're just writing, more recipes for them now for big migrations that people might be interested in or frameworks.
Interesting. All right. I'll definitely include links to that for folks in the show notes. So you can check those tools out. I'm not that familiar with them, but I'm just browsing around the OpenRewrite documentation at the moment, being like, curious. But
Oh, we also have COBOL, which I always forget
oh,
because it is such a friendly little dinosaur that we tend to forget runs the world in the background.
I just want to call back to one thing I mentioned, like because you were talking about like refactoring might be the boring part, and you want to work on new things, and I think that's an interesting distinction there. My podcast is about maintaining software. I am a mender, not a maker, and so it's like an interesting thing. I'm like, oh yeah, if I can just let the computers build all the new interfaces, and then let's see if the tooling that we're making actually gets used, and then let me come in later and help fix it. Is kind of like, let me improve upon things. I think that's mainly me coming from an environment of working with a lot of startups that quite often startups go out of business. And so it's just more of like, am I building something that will last for a long time or not? And so working on existing software, just kind of sharing my thought on this is like, I'm usually working on something that already has proven some business value and people are paying me to come in and help iterate on it and improve it. And I enjoy trying to unpack, and it's kind of like, that's the puzzle part for me, is like, how does this work? What were the people thinking when they made this originally? And how do we need to evolve it from here on out? And you brought up a good point, but like the fun part about refactoring is when you get to think about the design of things and like how maybe the design needs a change, or there was not that much design to begin with. So where is this going? Anyhow, I just wanted to kind of call back to that point. So I was not disagreeing with you entirely there. It's just more of a...
I'm just being editorial.
Yes. Let's go back to the report a little bit. The report mentions techniques like Retrieval-Augmented Generation, RAG for those, and then also Lossless Semantic Tree, LST. Could you briefly explain what these are and how I hear people talk about RAG all the time, and I'm like, I feel like I should probably raise my hand and ask, like, teach me a little bit more. So can you give me the kind of the layman's explanation, what the difference between these RAG and LST are?
Yeah, absolutely. So LST, Lossless Semantic Trees, that's basically from OpenRewrite. This is what we get once we parse your code, and we have this abstract syntax tree with a lot more information like type attribution and white space. So that's basically the Lossless Semantic Trees. This is what basically permits a recipe, an OpenRewrite recipe, to make changes to that Lossless Semantic Trees, which can then be, a diff file, a commit, and then you can push it to your code or whatever. So that's really the OpenRewrite stuff. RAG is, the other hand, more technique in general in machine learning. So the generation part, that's the, typical LLM, just generating text, basically. The idea with RAG, the problem was trying to solve was when we wanted generation that was related to a highly specific topic, and you didn't want to fine tune that model. So if we wanted to have something be used for, say, a particular library, a coding library, and you want to be able to chat with that chatbot about the library so that it can help you out. You can ask it questions about the framework. Maybe it can give you code snippets. So if you weren't going to fine-tune further that large language model, that LLM, onto that framework, that library, it might not give you very good answers because it's not an expert in it yet. What RAG does, you don't need to train it anymore, which, let's remember, training is expensive, GPU-wise, and it takes time. And you need a lot of data, which you might not for a certain library. So the idea with RAG is that you have a first phase where you retrieve parts of a database. It can be pages of the library docs. It can be examples of that library being used. Really, at that point, whatever that database is made of, as long as it's text and it's text that's related to what you're trying to make the chatbot an expert in, that's all good. So when you go to ask a question as a chatbot, how can I do XYZ? The chatbot will first take a moment to go and retrieve the most related documents. So again, whether that's an example or an actual documentation page. From there, the model then literally gets to read, it's part of its input context now. It gets to see those documents and then it can answer. So it's kind of like the difference between an exam and an open book exam. That's the way I would say it.
We'll be back with our interview with Justine in just a moment. Hi, it's me, Robbie. I just wanted to say thank you for listening to the podcast. If you're finding these conversations valuable, please consider sharing a link amongst your peers and/or writing a review on Apple Podcasts or Spotify to help spread the word. Also, is there someone you think I should have on Maintainable? Shoot me an email to robbie@maintainable.fm. And now, let's get back to our interview with Justine Gehring. I see. So it doesn't have everything necessarily stored ahead of time, but it can learn. And so is that kind of like contextual based off of your, like, say in your VS Code or something, and you have a couple things open, it's able to look at that stuff that you're currently looking at, and that in the moment is looking it up versus it's already kind of done some background research on your code base.
You normally want to ingest it ahead of time just because getting a way to retrieve those documents, normally you're going to do an embedding for every single one of those documents. So it's not necessarily something that's ad hoc or on the fly. So yeah, so it's more something you want to do ahead of time. But instead of it taking, a week to train a model, it's going to take you 10 minutes to ingest all your documents.
Can you tell me a little bit about, trying to, like, you're like having that human in the loop, you're still needing that to review changes for those listening that are taking, whether they read your book report. It's sorry, it sounds like it's a book report. You know what I mean? Your report book, ebook.
It's fine. I called refactoring boring. You called my book a book report. We're even now.
Your book report. No, if whether they were to read that or not, but like in terms of, like, for those listening that are taking advantage of, or trying to take advantage of, trying to figure out, like, okay, maybe I can play a little bit more. What sort of things are you seeing that developers are able to accomplish with some greater than 99% success rate? Because it sounds like you're worried about that 1% concern there. Some people might think, well, like 1% doesn't seem like that bad. You did bring up the example, like, well, if you have 1,000 switch cases and 10 of them there's a problem, like that's a problem. And people might be thinking, well, humans are prone to making mistakes too. But how do you kind of like line that up? That, at least maybe that counter argument. I'm not necessarily having that argument myself, but I can see I've heard people talk about it like, well, humans make mistakes all the time. So
Yeah, absolutely. And I think it's a fair point. I mean, I don't disagree. I think that's where, though, you want to make sure that you're giving all the tools possible to a human so that they don't make that mistake, right? So writing good test cases, that's going to be really useful. And that's useful also for AI generated code. When you want to use AI at scale to refactor, the part that we really like to focus on is kind of like the planning and seeing how can I really understand what's going on in my code. And that's the part I think that people kind of forget. They kind of just jump into it and go ahead and make changes when it's time to refactor. We had this client that wanted to change some provider for HTTP calls from microservices to microservices. And basically we said, okay, no problem. We'll write a recipe. We'll show you how to write that recipe. We asked them, okay, well, what kind of libraries do you use to make these microservices HTTP call? They said, oh, well, we use a Spring's web client and we use a OKHTTP3. Two things in Java. So we say, okay, great, no problem. We'll move from one identity and access management provider to another for both these libraries. So that's what we do. We write the recipe, or I forget exactly, I wasn't in the meeting, but so, they write the recipe all together. We show them how we can use OpenRewrite and recipes to do these changes at scale, and runs, make some changes. But then the client goes, ooh, I was expecting a change in this repo. And so then we say, oh, okay, well, that's weird. So we open up the repo, we start looking through it, and then we realize, there was a third library to do these HTTP calls, which was Spring HTTP headers. So we basically, had this work that was done, but had we taken a little bit more time first to discover what are actually the libraries being called inside the code before we start to make this migration, it would have saved some time. And so that's actually one of the AI applications we have that's really useful, is to search for method invocations just based on a natural language query. So this is something you could do where you could say, okay, well, makes an HTTP request, and then it'll find you all the method invocations that do that, no matter the library. And what's really particularly cool about that, if I could say so myself, is the first part. We actually use the type attribution to do a first search through your code. So having this extra information basically helps us then limit the search space later, because we have a better idea of what actually is being used. So we take all the method signatures and from there only look at the method invocations that use a particular method signature. So by doing this, basically, instead of searching through, millions and millions of method invocations, you only end up searching over 2,000, which then the AI can do what AI does best and say, yes, no, was this related to the query or not? So I think this idea of searching first before you go and make the change is really important to know what's inside your code base. And that's what's really useful as well about the LSTs that have that extra information, that type attribution, which lets you basically search faster because you already have the information you need at hand, basically.
What about for like using AI as a tool just to kind of help you come up with the game plan for how you're going to approach this stuff and when to leverage it? So do you find that there's teams that are using it as like, okay, as a developer, I got this task at hand. I need to do some refactoring or I need to build this new feature. How should I approach this particular thing? And given the context of my existing code base, without it just doing it for you. So it's kind of more of like your pairing buddy, or at least someone that's keeping you maybe focused on what comes next. Or have you seen some good patterns for that?
Yeah, absolutely. For that, I do think it's good. In the same way, it's great to discuss, code before you go and code it with a friend, a buddy, a colleague, whoever will listen to you, your rubber ducky. You definitely want to be able to have this kind of back and forth. And I do think chatbots are very good for that, definitely. And I think that's where we go back to the human in the loop, right? When it's something that you can verify, you can go search more about this thing. You might hear about a new concept that you hadn't heard about, or it might remind you about something you hadn't thought about. And then you can go ahead and search more about it. That's definitely one way that I use it a lot. I use, ChatGPT just as a chat bot and kind of try to get inspiration and creativity. And I think it can be really useful for that.
Likewise, I've been trying to leverage it more and more for different types of things as well outside of code. But I'm curious about, you mentioned also like how like code generation, something I hear and like I've heard different people talk about this was you're validating the work, the code generation, the code that the AI tools are generating for you. How are you doing that? And it's like, I've also seen people talk about like, oh, wouldn't it be great if AI could generate the test for my code? And then I'm like, this seems like an interesting trade-off. Like, should we be spending more time on writing humans spending more time on writing the validation code, the tests themselves, and maybe having AI help a little bit, but that should be the thing I would imagine you want to feel the most confident in, and so that you could trust the other code that it's generating versus I know my code works, I just want to have some tests to prove. Do you have any thoughts on like should you put a bit more time on humans on the testing side versus the generation side?
Yeah, definitely. I like the idea of being more careful when writing tests. I think people sometimes forget that writing tests isn't free. There's definitely compute costs that can come from it. And so to have a little bit more the human that can take a step back and really think and design the way they do tests in the way that they can be confident, I think that's very useful and an important part of making sure what you're releasing is good. For the other part to have, the AI run wild, you have to be really confident in your tests. And I think it's a good, first pass to definitely have the AI write some code for you. And like I said, I use it every day. Every day it completes some of my code. But I'm still the one double checking because I like to have that control on it. And I enjoy coding as well. There's that part, So as much as I can be like, oh, that was really useful recommendation. Yeah, cool. I hadn't thought about getting the length of this data frame using this way for, this subset or whatever. Cool. But I kind of want to be able to read it and be like, oh, that wasn't exactly what I wanted and whatnot. I think people also forget that language can be very vague. I mean, there's a reason why we don't code in language. We code with very, very, very syntax precise rules, and how we code because it can be really vague the way that we talk. And there's this classic little joke. Let me see if I can remember on the spot. Okay, so it's a partner tells their partner, okay, can you go to the grocery store and buy a carton of milk? And if they have eggs, get six. And that's when, the partner comes back with 6 cartons of milk. And then the original partner goes, well, why? And he says, well, because they had eggs. That's the kind of joke that makes you realize that, language is vague. And obviously, this is a programmer partner that's going to the store, and we can, as programmers, understand why this is funny. But, language is very vague. And obviously, this is just a silly little example. But even from one colleague to another, there's going to be iterations on what you expect the end product to be when you're coding. And it's super okay and it's super fine. And I think it's beneficial to have generative AI be one of those steps, one of those iteration. But like in many things, I think it code gets better the more you work on it and you kind of iterate on it. And so it's just important to keep that human in the loop.
Hey folks, it's Robbie here. I want to take a moment to share a little bit about my company, Planet Argon. Imagine us as your go-to spot for a pancake breakfast, where legacy software projects come to get a warm stack of solutions, drizzled with just the right amount of maple syrup. Whether you need staff augmentation to add some extra batter to the mix, or fractional development services to make sure everything's just right, we're here to serve up what your projects need. We specialize in tech stacks like Ruby on Rails, React, and Laravel. So if you know of a company that's stuck with technical debt, legacy code, or just needs a fresh dose of new features, send them our way. We'll whip things up and make sure their software is sweet and smooth. Visit us at planetargon.com. Again, that's planetargon.com. All right, let's get back to the show. And remember, the next waffle party's on us. I get that. And on this podcast, I try not to dig into like what's hot and new and what the trends are. I'm always like, we're talking about the day-to-day realities of software developers that are taking care of existing software projects. And we're not always in the business of making brand new things and starting with a clean canvas or blank canvas all the time. It's usually companies hire you to come in and work on existing software. You don't often get to be there day one when you get to spin up the new thing, and it quickly becomes existing software pretty quickly. And it has a lot of quirky parts to it, and you get to these, and so then there's these products out there like Moderne has, and like you're working with companies that have really large code bases and helping them refactor things. They're really challenging things for humans to kind of wrap their head around it, and so it's great that we can use the tooling to help us do stuff, but there's still this kind of like day-to-day thing of like, how do we get from A to B and just keep iterating and making our lives a little bit easier every day so that we can feel good about the work that we're doing, but also knowing that we're able to continue delivering for our customers and our clients and keep our businesses in business, et cetera, et cetera, et cetera. So I'm curious about, there are people listening right now that this is kind of an advice section. For those listening that might be working at a company and they've heard, not right now, maybe a couple of times when they may be like, hey, I want to try out some new tooling, or we need to take care of some of the maintainability of our software code base. And maybe there's some refactoring that needs to happen, or maybe improving the test suite, or they need to deal with some upgrades of their frameworks, or maybe even migrations. And they've heard not right now a couple times over the years. And so they've kind of stopped to ask because they feel like maybe they've been discouraged from it, or they don't think it's like nobody cares about it at the moment. What advice would you offer them on maybe how they can maybe start experimenting with some of these tools themselves to maybe help demonstrate that those larger refactorings or maintenance tasks? This might be a good time to maybe start actually advocating for that stuff again.
Yeah, absolutely. And it is such a problem. Everyone's just, managers included, just trying to do their best and have the most value with the amount of hours we have. Unfortunately, there's still only 24 hours a day, at least for now. So, we're doing our best. It's definitely a challenge to decide what to work on. I think, when you use Moderne, we have these recipes that aren't AI, right? Those are changes that people code themselves. They write the recipes to make these changes. One of the things that can kind of get a return on investment, where here the investment is even the hours that you put in writing a recipe. It's a good tool to show, look, I was able to migrate, these projects to this version if you wanted to upgrade something or to go from one provider to another, like the other example I gave. So to be able to show the amount of hours that are saved by using a recipe, it's definitely one of the ways that you can motivate. We have a very talented person in our company called Mike that writes docs for OpenRewrite and Moderne, and it kind of makes the barrier to entry a little bit easier for something that can be at first intimidating. I didn't come from the Java world at all. I knew Java, but I didn't know it industry wise, and I certainly hadn't coded in it for years when I started at Moderne. And I was able to write recipes, pretty quickly. I think it didn't take me really that long to be able to write. Obviously, I had access to people to ask questions to, but we also have a Slack for OpenRewrite where you can become a contributor and you can ask all your question and everyone helps each other. And there's this community where we really share recipes with one another, right? What's great about this is once you code it once, you can keep running it automatically on a bunch of repos. So if you're able to show enough value on one big repo, one mono repo, or a handful, 10 or something repos, imagine if this is now being used on 1,000 repos. And I think it's a nice tool to have in our pocket to be able to say, I think this is something worth investing in. And whether you want to go on the open source route with OpenRewrite, or if you want something a little bit faster that can be used at scale, then Moderne definitely is more the solution. There's that foundation work from OpenRewrite that can be really useful. A month ago, we saw a job posting actually where they had knows how to use OpenRewrite and write recipes in the requirements, and that was kind of fun to see. Where it was like, great, it's not even a company we know, and it's fun to see that it really has an impact, and it's something that you can kind of say, okay, I'll work on this for a week, but then a lot of the refactoring will be done automatically, and you just have to tie in the ands at the end and do the design part, which is you have more time to plan now your migrations and your transformations.
Well, cool. I will definitely include again links to those tools in the show notes for everybody. And with that, I have a couple of quick last questions for you. Is there a non-software development, non-technical book that you find yourself recommending to peers?
The one that comes to mind is Getting to Yes, which I think it's funny because we're just here talking about, negotiating with your manager or yourself about what to invest time in. And I read it pretty young. It was a while ago, but it really opened up my eyes on why it's so wrong to think that when you're negotiating, you're just negotiating on a percentage of the pie. Oh, I want to get this side of the pie and you want to get this one. The idea is really to be able to ask really good qualifying questions to understand where both parties are coming from when negotiating something. And it's a very short book. I think I read it on one plane ride somewhere. It was a really sweet book, and I definitely recommend it. It's more on the social science side of things, but I think anyone that deals with people in their everyday life, even if it's just colleagues, I think it can really help us all learn to take a step back and realize that when we're negotiating so ferociously without, when we're blind to what actually are, I want to say almost opponents, but whoever you're negotiating with, whatever their needs are, you are actually being a detriment to yourself because you're not realizing where both parties can be happy.
Nice. I'll definitely include a link to that. I've actually not read that book. I read a couple different books about negotiating over the years, and that one's been referenced before. So I'm gonna pick a copy up, and I have a plane ride coming up, so we'll see if I can get through it.
Oh, perfect.
And where can listeners best follow your thoughts and ruminations about software engineering and AI online?
I'd say LinkedIn. Definitely LinkedIn is where I'm more active.
Include links for everybody so they can go find you there. And with that, it's been such a delight having you join us on Maintainable, Justine. Thank you so much for stopping by to talk shop with us.
Absolutely. Thank you so much for your questions.
Maintainable.